Good morning, students. Today we will start the lesson number 2, work and energy. First question is, what is work? Now, suppose I am pushing the wall, I am rubbing the board, or I am pushing the table. Am I doing any work here? According to us, any mental or physical activities which is done by us is a work. But according to physics, it is not so. There is a proper definition given for work which we have to understand today. Now you can see on page number 19, figure 2.2, displacement of an object is shown. The A example is Meenakshi is trying to push a wooden block on the surface of table from direction A to B. So Meenakshi is pushing the wooden block on this surface of the table. So she is applying a force on the direction on this from left to right, and it is making a displacement in the same direction. So here work done we can write force into displacement. The second example, that is figure B, you can see a small child is pulling a toy cart. When that child is pulling the toy cart, she is applying force through her hands on this string. So the direction of this applied force is here, whereas the cart is moving on the horizontal surface. When the cart is moving on the horizontal surface, it is making an angle theta with the force applied on the string. Then the third example, where a large vehicle is towing a small one. Here also the direction of the force and the displacement are different. So in these cases, when force is applied along the direction of the string, in both these cases the direction of force is making an angle with the direction of the displacement. Now we have to calculate work done in such cases. Now we will take the second example, where force is applied by the girl on the string is making the toy car to move in horizontal direction. So here it is making a displacement from left to right, and an angle it is making is theta. This is the direction of displacement. Okay. Now we have to calculate the work done. In order to calculate the work done, we have to convert the applied force into the force acting along the direction. Now applied force here we can take as F and the actual force as F1, which is happening from left to right. So here we know the formula W is equals to F1, the actual force, into S. Now we have to calculate F1. For this, you can see it is making a right angle triangle. So we can use the rules of trigonometry to find out the value of theta. that is angle made by the string to the actual direction of the force. So here theta we can get by cos theta, which means base upon hypotenuse. You can see in the diagram, base is F1, hypotenuse is F. So cos theta is equals to F1 upon F. Now we have to find out F1. F1 we can keep here and cross multiply. So F1 is equals to F into cos theta. Substitute this value of F1 in the actual formula. So we get, substitute F1 in equation 1, we get W is equals to F into cos theta into S. We can rearrange this. We get W is equals to Fs cos theta. So this is the condition of actual work done when an object is making an angle theta with the direction of the displacement. Okay. Now, in your textbook, there is a table shown. You have to use this formula in different values of theta. So, how will you use? Three angles are shown: 0 degree, 90 degree and 180 degree. So, here when we have theta 0 degrees, that time cos theta, that is cos 0 is equals to 1. Okay, so we have the formula W is equals to F into S. Got it? Because cos theta is 1. The second example, when the theta is 90 degree, that time cos 90 degree is equals to 0. So it will be W is equals to F into 0. So W becomes 0. That means when the applied force is making an angle of 90 degree with the displacement, the work done is 0. For example, the coolie is carrying the luggage on his head and the direction of force is downward, gravitational force, and displacement because of the movement of coolie, it is making 90 degree. So cos 90 degree is 0, work done is 0. Next example, 180 degrees. When theta is 180 degrees, cos 180 degree is equals to -1. So what will happen? W is equals to minus F into S. Means when angle theta is 180 degree, work is in opposite direction of the displacement and the applied force. Now you have to write the definition of work which is given on page number 18. Mark that work is said to be done when a force applied on an object causes displacement of the object. You have to also copy down the calculation of work done when angle made is theta, and you have to copy this table from your textbook. Okay, write the conclusion. For 0 degree, you will write that work done is in the same direction of applied force. Second, for 90 degree, work done is 0. For 180 degrees, you will write force and displacement are opposite to each other. Now we have to understand unit of work. We know that W is equals to force into displacement. The SI unit of force is Newton. The SI unit of displacement is meter. So we can write when the 1 Newton of work done making a displacement of 1 meter, then work done is 1 joule. This is your SI unit of work done. Okay, when the definition of 1 joule is when force applied on an object is 1 Newton and making the displacement of the object 1 meter in the direction of the applied force, then the work done is 1 joule. Got it? It is given in your textbook also. This is in MK system or SI system. 1 joule definition you can see. If a force of 1 Newton displaces an object through 1 meter in the direction of the force, the amount of work done is 1 joule. The next one, in CDS system. Again we have the same formula, force into displacement, but in CDS system, force we give the unit as dyne and displacement in centimeters. So work done when 1 dyne of force applied makes a displacement of 1 centimeter is known as 1 earth. This is in CGS system. In your textbook, the definition of 1 hour is given, underline and tick mark. If a force of 1 dyne displaces an object through 1 centimeter in the direction of the force, the amount of work done is 1 hour. Okay. So from this page 20, you will take down the definition of joule, 1 joule, and definition of 1 hour. Then relationship between joule and hour. How we show the relationship between joule and earth? We have the formula of work, that is W is equals to force into displacement. Now we have to find the relationship between joule and earth. Now how do we get joule? If the force is 1 Newton and displacement is 1 meter, then the work done is 1 joule. Okay? So I can write 1 joule is equals to 10 raised to 5 dyne into 10 square centimeter. So it becomes dyne centimeter. Dyne centimeter is your earth. Means 1 joule is equals to 10 raised to 5 plus 2, 7 earths. This is your relationship between joule and ergs. Okay, so you have to take down the relationship between joule and ergs.